in this video, I'm going to be breaking down Java as a programming language, which is going to help you pass your Java interviews if you have them. I used Java for 2 years at Citibank. I used it all throughout college, and I just did some studying for a Java role and kind of put together this guide for myself and figured, hey, I might as well just share it. If you're wondering like why we're doing Java, well, one, Java is like one of the most used programming languages in big industries, right? So if you look at companies like Citibank, right? Before I got my Citibank offer, they tested me on my Java knowledge. Capital One, Walmart, there's tons and tons of jobs that are just like the kind of boring ones, I guess, like AT&T, Home Depot, Chick-fil-A, like they all need software engineers and they all probably are using Java. Just because it's like, it's popular, it's in, and it's for like these kind of old infrastructure, like not big tech, not startups. They won't get you won't get jobs doing it that way. But knowing how to do like these concepts, studying them up for yourself is going to set you up, I think, for that. So here is the Java cheat sheet that I made, and these kind of compose of like, when I hear Java, like there's maybe like 6 subtopics that are inside of it, and 6 or 7, whatever, subtopics that are inside of it. And what I want to do here is just kind of go through each of these topics to make sure that you understand it, to make sure that you know what's going to be happening. Let's get into it. So, first thing we've got is like object-oriented programming. Like this is like #1 de facto, big part of Java. If you do have a Java interview, if you're looking for a Java job, if you're looking at some kind of company like there and you don't know what this is, you're massively behind, because they're very, very, very likely going to ask you something about this. Then we've got generics, wrapper classes, auto boxing, more things that you again should know, which is just kind of this concept of a wrapper class. We've got Java keywords, so you can also be like tested on trivia at these companies. Again, Citibank, Walmart, Capital One, I mean, the list goes on, Chick-fil-A, AT&T, whatever. Java keywords, you got to know them. Garbage collector, what is it? What does it do? It's a very unique thing in Java that's not really talked about in Python, a little bit, but not too much. Lambda streams, this is advanced. Don't necessarily need to know it. Common errors that you come in through with Java, though, you need to know that. Like, what are the common errors that you face when you were coding in Java, or that like other people would face when they're coding in Java? Because if you understand the errors, you can code faster, you can debug the errors faster, and things are just better. And then we've got the collections frameworks, this is for the Leetcode section type of stuff, and for data structures, algorithms, very useful for that. And so what I'm going to do now is we're going to go through all of these topics. I'm going to explain them, break them down to my understanding of them. Now that you know these, I would recommend you study these yourself, because I'm going to be going them very quickly. But in lieu of that, we'll have this out. So let's talk about object-oriented programming. This is like the bread and butter of Java. And it's like object-oriented programming is this idea that like, instead of just coding and writing functions, so like when you were in college or whatever, when you were first learning how to program, you were kind of taught that there are functions that you can have, and then you would have like some function here, right? Like f, and then you would define it, and then you would just keep doing that for every single thing else. Now, so you would just copy, so you'd have like this long code. Now the problem though is that this code gets really, really long, and it's really, really confusing. Like you don't know what's happening here. After this gets to millions of lines, hundreds of lines, like there's like things that are like referencing other ones, like this function actually calls like this function, and this function like goes over to like this function, and it's all like super, super conglomerated. So object-oriented programming was kind of born, and it's the basis of Java. You must actually code into this format, and this format is like, you don't do what I just described, but what you do instead is you build out like these little blocks. So like if you're going to build a car, you would say like, okay, well, there's going to be an engine, and then you say, okay, well, that engine is going to be composed of, there's going to be like a radiator, and there's going to need to be gasoline, right? So then there's a gasoline, and then you need an alternator, of course, right? But like, it's this idea that like you take all these parts and then you just start like piecing them together. You define the relationships. Oh, well, the engine can have like a little piece that's called like a spark plug, right? And so then you can put like a spark plug here. But the kind of idea is that like engines can have things. You can do this with anything, but like the TLDR of object-oriented programming is that things can have relationships. And there's actually 4 tenets of object-oriented programming. And so this is something that you will be asked. What are the 4 features of it? What do each of these things even mean? What's encapsulation? What's polymorphism? What's inheritance? What's abstraction? And encapsulation is this idea that like, one we kind of already talked about object-oriented programming. I do want to answer this question, right? Which is, encapsulation is this idea that we can abstract away certain types of features. So if I have a function, again, we're talking about functions. So we have like an engine, and let's say we've got like, and it's called like start engine or something. We can modify it to where like these are hidden and that nobody would actually be able to see like the start engine like feature, because maybe that's like super complicated. Like maybe start should be public, like we want people to know about that, but we don't actually want to know that like an engine like transfers oil, right? Like we want to keep that hidden. And so what we can do is we can abstract away things and keep them hidden. So this is the idea of encapsulation, is that we can keep the things that we want and then don't show the things that we don't. And this is going to decrease complexity. It's going to help allow us to build out these systems that are like pretty neat and tightly, put together. So polymorphism is this idea that like we can have things that can change their features. So if we want to convert engines, and again, maybe we want to stick out to cars, maybe cars is like, a bad example, but like, let's say we've got birds, animals. Let's say we've got a bird, right? We've got a bird and we want this bird to like a penguin, to be a part of it, right? So we got like, okay, well, there's a penguin, right? But basically is that like this idea is that this penguin can inherit from a bird, right? So we can place a relationship. And so this would be is a relationship, right? So is a penguin is a bird, or bird is a penguin, same thing. But like you can establish some kind of relationship between the two, right? Now we've got inheritance, which is the idea that you can take on traits. So if something is a bird, then it can fly. And so you can actually pass down traits to things. And then abstraction is this idea of you have like a layer, and you can define like certain kind of features, I believe. Like you can kind of define features on as to what like it should do. Granted, I might be wrong on this actually, but these are the 4 things that you would be asked in an interview. Like you'll usually just be asked to name them, but it is important too, because they may ask you what is polymorphism. And again, like I've done this for 5 years. Like I was asked these types of questions, and this is why I'm bringing it up to you. Like if you interview for a Java position, like it sucks that like I spent 5 minutes or whatever explaining this. But hopefully, like once you ace all of this, this is where the bar is. I don't think is that high, but like you just need to know this. Okay. So then we've got the solid principle, and honestly, like I don't even know this fully. Like I know it's like single responsibility principle, open closed is what this O means. Liskov, like law or something, or principle, independent injection or something or whatever. I don't know what these last two mean, but like for solid principle, it's just this idea of like we're gonna TLDR this super hardcore because I don't even know what these are, and like by name I think it's kind of cringe, but like basically it's like single responsibility principle is the idea that like an object should be its simplest component. It should not do a whole lot of things. Like a engine, let's go by here, an engine should not be focused on like managing the state of the car or creating like the suspension. Like the engine, just let an engine do what an engine does. And when you take this, you just get things that just simple, which is you're gonna see this pattern coming up a lot with object-oriented programming. But like single responsibility, a object has one responsibility. Right now, the second thing here is that this open close principle is that we want people to not be able to modify the engine, but if they want to add new features, they can do it. So that's like the open close part of this, which again, not a crazy kind of idea, right? Is that like we don't want people to be able to change what an engine can do because that'll break our code. But we also do want them to be able to add features to it that aren't going to break the code, right? Because sometimes engines change. Sometimes you get an electric vehicle, right? Years later, Elon brings out a Tesla, right? So our electric vehicles, and they're all the rage. So now we need to make a little change here. Liskov's principle is this idea that like we don't want to have things that are contradictory. So the example of this, I think, is like a square and we have like a square and then we have a rectangle. There's a relationship between these two things, which is that a rectangle is a square, but not all squares are rectangles. But it's basically that when we form the relationships between them, that like there should never be a conflict. Whereas we're saying that like because the square inherited like the rectangle, then that means that like the functionality within it, like these functions are going to be different. Basically, right, so you can have like calculate area or whatever, calculate perimeter. For a rectangle, it'd be slightly different because it's like 2L times, it's like length and width because they're different. But like basically you just want to make sure that there's no conflicts here that when it inherits something, like you're not going to have like some kind of weird conflict. Okay. And then there's design patterns. So factory, singleton, strategy. Again, these we can go over and over again. We can make a 1-hour video just on all of these. You can look these up if you want. Like it's just gonna be, I think it's just relevant to know, but I think it's out of scope for this video. I think it'll take too long. But a design pattern is this idea that like there's only so many situations in life and in programming, and so we're not gonna see too many different things. And so it's like, why not just remember what these patterns are? It's the same thing too with this Java stuff. Like if your Java interviews, like these are patterns. Like there's not that many questions on Java that you can be asked. There is an actual limit. It's not unlimited. So we can just learn these, memorize them. Then when we have the actual test, pass it, right? The same thing with design patterns. We don't have to memorize, like we don't have to reinvent the wheel. We can just memorize the common patterns because they're limited and then just use them when we want. And that just makes life easier. And if people are talking about like, what about this problem? What about this issue? Like you just talk, hey, what about factory? And you already know what the code base looks like. You already know like how to structure it. This is object-oriented programming. Like I think if you know this, you're probably fine for an interview. If you know these things. Abstract class versus an interface. Abstract class is the idea that you can define unimplemented methods that people have to implement later. And then in a interface in Java is that you can only have unimplemented methods. In an abstract class, you can actually mix and match. So you can implement methods and then also define the ones you want. And I think in Java 8, they changed some things up here too, but that's my insight. But I think you're honestly fine. If you know these, you always get it like half of them right. And let's go let's go to garbage collector. So this is important too. Just like how does Java work on an internal level? Like first off, we have the JDK, we have the JRE, we've got the JVM. These are all like kind of components of Java. Now, honestly, again, I forgot this. I don't know what these actually do. But basically is that like you're going to have like something that is going to be running, like these are like the library code or like library code, right? So this is the code you write. It's going to be referencing some types of libraries. And I believe that maybe where the JDK comes in. Honestly, I actually don't know. But just doesn't, I mean, it's something I could probably look up very fast. Unfortunately, I'm probably not the best person to be teaching this. But essentially in Java, like you're going to be having like some kind of code. That code is going to be going into like some libraries, right? So you write code, and that code always is going to be referencing like some kind of library, and it'll just pull up and reference the libraries. So these are where class loaders come in. So there's a bootstrap class loader, extension, application, but there's like levels to this. So this is level 1. If it's not here, then it goes to here. If it's not here, then it goes to here. And if it's not here, then it throws an error, like a class not found error. The code's going to reference it. And then once it's good, once it's there, there's going to be a compiler, right? Which will take the code and it's going to chunk it up, pass it into the compiler. And then it's going to give us a beautiful, beautiful Java file. And this is where write once, this is a saying in Java, write once, like run anywhere. Because once the code is here, you can just run it from any application and just transfer it over. And when it gets transferred, it reads into the Java virtual machine, I believe, reads it. Turns it into this byte code and turns it into like C or C++ or something. Honestly, yeah, don't really remember, but it is something that you will be asked. Unfortunately, I'm not going to be asked it, so we're good. How does garbage collector work in Java? So anytime like something is not referenced. So one is like, okay, well, what is garbage collection? What is this idea? It's the idea that like when we have a Java class and we're building out all these objects, well, that takes up memory. Like you can't just like forget that an object exists. Like something needs to be remembering it, right? So there is a thing and it's called like the heap, right? So we've got like the heap. And what this thing is going to do is it's going to keep track of memory. So it's going to say like, oh, well, you made an engine. Okay, cool. Oh, you made a car. Okay, cool. Well, sometimes the heap you can actually run out of space on the computer. Like computers don't have infinite memory. And so when that happens, you get an error. And that error says there is no memory left. You have to delete the memory. Now in Java, they simplified it. So the way of deleting memory in C++, I think you have to delete everything manually yourself. But in Java, they made it nice to where you can have a garbage collector that does it for you. And what it does is it says, hey, if nobody is using this object, let's delete it. And it doesn't tell you when it's going to delete it. It doesn't tell you how. Maybe it does tell you how. I mean, it just deletes it. But it doesn't tell you when it's going to do it. But it just does it at some point. And that will just free it up. And these are specifically done by reference points. So if an object points to another object, then it is safe, as long as it's even pointing to. If nothing is pointing to it, then it is not safe. And that's that. So that's garbage collection. That's how it works. That's how it works in Java. At compile time, I believe, is when it'll start getting run, I think. And then you also have a method that you can call to actually try to do it, but it doesn't listen to you like exactly. But yeah. So there are 4 types of garbage collectors that you have in Java. So there's like there's like a parallel programming one. So if you're doing that kind of stuff for multi-threading. And then there's also like 2 other ones that are more optimized for like low latency garbage collection. And I think other one for maybe multi-threading at the same time. I don't actually remember, but you could look them up. Ask ChatGPT or something. I don't know, but Again, this is just an intro. Obviously, you can probably tell too because I'm literally explaining what object-oriented programming is. So this is very, very intro level. Next thing, let's go over some Java keywords. So like, what is static versus final in Java? This is a question you can be asked. What is throws versus throw in Java? What is a lambda expression? What is equals versus equals? What is equals versus hash code? What is finalize, finally, and final? What are public and private methods? What is protected and default? What is reflection? These are all kinds of things about just random Java keywords that you could be asked in an interview. We're going to try to answer a lot of these, right? So equals versus equals. So dot equals references the object, and equals is for primitive types. And so this is where we kind of maybe have to jump into here. Like, what is a primitive type? What is a reference type? So primitive types in Java. So in all programming, right, you've got types of data you can store. So you've got heaps, not heaps. You've got integers. You've got like, and an integer is like a number, obviously like 1, 2, 3, 4, 5. You've got strings, which is like hello, right? And then you've got like bytes and things like this and so on. Equals is used for comparing like engine, right? So like, how would I compare an engine and engine? Well, I can't because they're abstract concepts. Like they don't actually exist, right? We could talk about Jaden Smith. Like, do we even exist? How can we be real if our eyes aren't real? No, but like the engine, it's just a abstraction. It's just code. And so we can't just put an engine equals in an engine. We have to define that. So you could, use some kind of dot string method and use dot equals, and it'll work for objects. Now in equals can actually just compare things directly, literally. I also think equals uses memory, compares like the memory if nothing's specified. And then equals compares the actual content. So it'll compare the actual numbers here. So that's going to be the difference between equals and equals is that you would use this for primitives, and then you would use this for objects, and I think define them too. And for the primitive types and reference types, so we talk about these integers. Well, in Java, you're not allowed to really do some things inside of containers. So like array lists and things like that. Like you can't really hold primitive types. And so they made a thing called reference types, and these are generics, right? So you can pass in some kind of like thing here. It's an integer, which is a wrapper class over the integers, and you can perform operations on it. And so like instead of doing like, like the actual primitive type is like an int, but like its wrapper class is called an integer, like the reference type, it's an object. And then you've got like string is an object too, but you've got like char, like character with like char, I believe. But I running out a little bit of time here. Okay, no. Okay, we're good. We've got char and then we've got like character, whatever. And the idea of auto boxing is that like, if we want to convert an integer into its object form so that we can use it into an array list, well, then we've got to convert it, but Java will automatically convert them. So if I put in like a number like this and it's defined as an int, it will automatically become like an integer. And in the same in reverse. So then there's also like unboxing. And so generics is like the things that we're kind of putting inside here, which is like these things. Like it's like an object that holds like another object. And so like because array list can hold objects, it needs to convert the primitive types into an object. I imagine you could think of it that way. Okay, cool. And then we've got equals versus a hash code. So if you're using hash maps or some types of collections, and you want to see like, is this hash map equal to this hash map? Or like this key in the hash map is equal to this key, as opposed to like scanning through the entire hash map, what you can do is like hash the values. So then like if there is a conflict, then you can kind of keep going basically. Weird, but like imagine if you have a, like you've got like a hash map of like students, and you've got like Alice and Bob and things like that, and you want to know like, is Alice inside of it? Well, then you would just check, like you have to hash Alice, and then you've got to like check, you would hash Alice and you can check, but sometimes there are collisions, and so like you can have multiple values that can be Alice, and then when there are multiple values that can be Alice, you've got to check through all of the possible collisions to see like which is actually the true Alice. I think you hash Alice and just compare those, or you hash like the values that Alice has. But basically it's a way that you can save time when you're looking at collections. Okay, finalize is the idea of the garbage collector, what we talked about earlier. So finalize will say, hey, do these things after you or before you garbage collect it. So it is going to be destroyed. It is going to be removed from memory, but like I need you to do some stuff beforehand. Finally is used in try catch methods, and then final is a constant essentially. So it's something that you cannot change. It's a variable you can't change, right? Like a constant variable. Static is a Like it's a commonly shared like variable for a class. So if you change it once, you change it for all the objects that it belongs to. You can also do static methods, which you can prevent people from overriding it. And I think there's a couple of other things here too. Final is the idea that, which is the idea that I just said, which is constants, right? Throws versus throw. So throw is used in try-catch blocks. Throws needs to be used to define unchecked exceptions. Well, at least there's checked and unchecked exceptions. But like essentially is this, that like there's some exceptions that need to be explicitly specified. And so you have to say like it throws this, it can throw this exception, or else you'll get an error message. And lambda functions are just like a neat way that you can provide shorthand code, accumulating and putting single line functions and all that. Okay, cool. Collection. So we've got a hash map, which you should know if you're looking at my channel. Tree map, which is a like binary search tree. I think it might be a red black tree, but that's super nice if you need to do login operations. Set. I don't think hash that's a thing. I think it's just set. And then we have dex, which is basically the queue, useful for breadth search, and then we have priority queue. But if you know how to use these things, like these also work for stack too, by the way. Dec works for stacks. But if you know how to use these in Java, like you're probably a force to be reckoned with for DSA, I think. Honestly, like I only know how to use hash map and then set and then dec. Actually, I don't know how to use priority queue. But in Java, because again, I'm not a Java person. I do Python mostly, but knowing these will get you past some interviews, because most interviews are really just like array based. I think for Java position especially, like you won't see like a dynamic programming question and at like Citibank, I'd imagine. Okay, cool. We got common errors, null pointers, array out of bounds, class not found, IO exception, file not found exception. This was probably something you would want to use throws for, file not found. Stack overflow, like no memory and all that stuff. Stack overflow is usually infinite recursion though, I think, in a function. And yeah, all that. So you can look those errors up, see when they come up. And then this isn't necessary at all. You just have like some nice clean one-liners if you can use streams and lambdas. But anyways, so this is the Java cheat sheet. This is what I did to study, for Java interviews. I've been asked these questions, so all the content that I kind of went over, these are questions that I've been asked, at companies. I've been asked, like, what does static do in Java? What is the garbage collector? What does that do? What is object-oriented programming? Like, I've been asked all these questions. And so like the kind of thing that I want to take away is that like, if you don't answer these questions, and the reason why I'm going over is because if you don't answer them, you're not going to get the job, and it's probably going to be because of this question that you're asked. And so hopefully this helps you, this cheat sheet. Hopefully my explanation kind of helps. And again, if you didn't understand something, I would say like just go ChatGPT, look it up, try to learn something, and that is that. If you want to do more learning, you can also hop into my school group where I do like weekly Q&As, like I talk to people and answer questions that you have, live. And so if that sounds interesting, click the link in the description. And that's it. It's also only for like people in the United States, because I don't know like how to like do interview stuff. I can't help you with interview stuff, honestly, if you're not in the US, and you have to actually have a like 1 year experience. But got my Discord, which is free for anybody, and then got the school group where I actually offer some additional stuff. Hopefully this is helpful, and quite a long video, and I'll see you guys. I think we're going to be going pretty hard on videos, so I'm going to be putting out more and more and more, seeing how that goes. But peace.